is a world-renowned mathematician.
What did he do that was so great?
He extended the method of exhaustion.
What's the method of exhaustion?
It is used to determine the area and volumes of curved lines with surfaces.
Like what?
Circles, spheres, pyramids, and cones.
When are we ever going to use the method of exhaustion?
When you are older, you may take a class called Integral Calculus.
Okay, hi, I am Archimedes. Yes, I'm Archimedes. And I'm about to teach you my method of exhaustion in the simplest way possible, I believe. Why would we use the method of exhaustion? To find the area of any flat shape. So, first off, again, I'm Archimedes, and no, this is not a whiteboard. So let's just assume that this flat shape is a circle. Okay? And I want to find the area of this flat circle. So what I am going to do is I'm going to circumscribe a polygon around it. Now, a polygon, you should know, is a figure with straight lines, such as a square, octagon, etc. So let's do a square. Circumscribe means that when I draw this square, it remains on the outside of the circle. However, each side of the square will touch the edge of the circle. Now, I'm going to inscribe a square, okay? So that means it's inside and each corners is touching an edge of the square, of the circle. So basically what the method of exhaustion is, using, your calculations and measurements, you find the area of this square. So the area of this square is obviously going to be greater than the area of the circle. And this inscribed square is obviously going to be less than. So for example, just basic, let's say the area of this outer square, this circumscribed square, is 11. Don't know why I'm writing sideways, but let's just say it's 11. Let's say the inscribed one is 9, okay? That means you can approximate that it's going to be about 10, this area of the square. Now, that's basically if you just want a rough, very rough estimate. Another way of doing this is, let me draw my circle again. Like I said, use any polygon. So let's use an octagon. That, I think, is going to work. I don't know if this is going to be an octagon, but it's going to be quite a few-sided polygon. So let's start with this. Yeah, this is not going to be okay, so yeah, I know that. Okay, well, pretend like this whole thing right here is closer to. It's much closer than when you had a square. Okay, it's going to be more accurate. So then again, we're going to inscribe. Let's inscribe another octagon. So I'm going to inscribe one. I'm just doing it roughly. Takes way too much time right now. Okay, so I'm going to inscribe. Obviously, the circumscribed octagon is going to be greater than The inscribed is going to be less than. So, therefore, you could get a more exact measurement. So, maybe now we know that this is 10.5 and this is, I don't know, 9.5. Now you know basically for sure, almost, that it's going to be very, very close to 10. Contrary to before with the square. That basically is the method of exhaustion, my method, Archimedes' method of exhaustion, in the simplest version possible.
Actually was the closest person of his time in determining the value of pi.
Wait, you mean the pie we eat? I love apple pie.
No! Pi is the number that gives the ratio of a circle's circumference to its diameter.
Oh.
And he was also an inventor.
What did he invent?
The world's first sea-going steamship was the SS Archimedes, and it had a screw propeller based off the Archimedes screw.
Why do you think he was so smart?
It's probably because his father, Phidias, was a well-known astronomer. However, he didn't really get to know his mother. He also went to school in Alexandria, Egypt, which was then considered the intellectual center of the world.
I want to meet Archimedes right now.
Well, I'm afraid that can't happen. He died almost 2,000 years ago.